So hey guys, welcome back to my channel. Hope you are doing extremely well. This is your very own mask code this side, and today we're going to solve the 30th day GFG POTD, that is find duplicate rows in a binary matrix. So let us have a look at what is the problem. So the problem says that you haven't provided a binary matrix. That binary matrix is each cell either contains 0 or 1. All right. Now you have to return the row numbers which have already occurred before. That is, so here you can see this is a matrix provided to you. Now you see that 11010 is your row number 0 according to the 0 base index. Okay. Now 001001. Okay, you can see that this row, the same row has not occurred before, right? This is your row number 1. Let me mark the indexes first. 3, 2, 3, and 4 and 5. All right. These are the indexes of the rows. Now you see that 101100 exact row has not occurred before, but the next row, that is double one zero double 110101, that is this row, is actually as similar as this row, the first row. So my answer will contain 3. All right. Now 001001, this row is equals to this row, so it will also occur 4. Again, the fifth row is also equals to fourth and equals to 1. So my answer will also comprise of 5. This is my answer. So that is, we have to provide the zero base index of the rows which have already occurred before. The similar pattern has already occurred before in the matrix. I hope the input and output is clear to you. Okay. Moving down to the approach. So as usual, we will discuss the brute force, then the efficient, and then the optimized. So the first approach should be brute force. How can you check for brute force? Very simple. Start from down. Start from down. You can also start from up, but I'm starting from down because it will be comparatively easier. Start from down and check for every row. Check for every row as soon as you discover a row similar to your current. This is the point number 1, this is point number 2, and this is point number 3. Similar to current row, push the index into answer. That is, as you start from this row, okay, you see that the next row is uh, the same, so put 5 into the answer. All right. After this, you see for 001, for 0 for the fourth row, you check third, then second. When you come to first, you realize that this row is similar as 4, so you put 4 into the answer. Then checking for third, you will check second first, then first, then 0th. After coming to 0th, you will realize that 0 and 3 are similar, so you will put 3 into the answer. And for 210, you will continue the same steps, but you will not find any good results. So final answer will become 3, 4, 5. All right. So what is the code? What should be the code? Let me write it down. So the code should be for I moving from n minus 1, assuming this is a n cross m matrix. Okay, n minus 1 up till 0, not 0, up till 1. Why 1? Because the 0th row cannot have a duplicate. The 0 is the first row, so it cannot be similar to any above it. So move to the first only. Now for j, from I minus 1 up till 0th, here will come a 0th and I minus 1. Okay, if row I equals to row j, in that case answer dot push back I, and then break, most importantly. Okay, this loop will break and it will move for I first, for the ith value, that is the next index. All right. Time complexity as usual, O of n square. No, this is only for traversing. But for checking, what you will do, how can you check? For checking, how can you check? You have to check each index, that is 0, 0 with this 0, 0 with this 0, 1 with this 1, 0 with this 0, 0 with this, 1 with 1, then only. So actually you are taking m operations always. So it will run n times, it will run n times, and it will run m times. So it is O of n square m, that is row square columns. All right, the space complexity is O of 1. That cannot, I cannot deny that. Okay, but pretty inefficient. Actually, it is kind of cubic, pretty inefficient, right? So have to move to a, what do we say, efficient algorithm. Okay, the efficient algorithm now. Efficient algorithm, I have two approaches for you. Two approaches. I will tell you the easier one first. All right, so let me copy down the matrix below. So the first approach would be using bit manipulation. Simple bit manipulation, don't be scared, it is not a hard one. What I'm doing is I'm calculate decimal equivalent of each row. If you observe carefully, doesn't it look like a binary sequence, 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 a binary sequence? So I'm saying if two rows are equal, the decimal equivalent will be same, and if two rows are different, the decimal equivalent will have to be different, right? So what I'm saying is calculate the decimal equivalent of each row. If that equivalent has already occurred before, that row is duplicate, right? So calculate decimal equivalent of each row. If that equivalent has already occurred before, that means the row is duplicate. Else, if the row is not duplicate, then else push that equivalent into your data structure for future references. Into your data structure. What data structure can you use? You can use a map or a set. A set is pretty much appreciated in this because you have to find if it has already occurred, and set does not contain duplicate values. All right. So this is my case. Now let me try run it for you. So if you see, this is 1 1 0 1 0 1. It will be 0 1 2 3 4 5. So the first equivalent is 1 plus 4 plus 16 plus 32, which will be equals to 20 plus 50, 53, right? Second one is 1 plus 8, that is equals to 9. Third one is again that is 53 only, we can see it visually, so I'm not calculating it again, and 53 occurs, 53 is already present, so my answer should be 3. Moving to the fourth row, that is this row. It is 1 plus 4 plus 16 plus 32, right? Okay, so this was not 53, right? Sorry, this is 53. Sorry for my mistake. This is 53, so 3 will be my answer. Fifth row and sixth row will give the equivalent of 9 only, you can see. And this is my case. All right. Complete dry run. How would you write the code for it? The code would look something like this. That is for int I going from 0 up till n minus 1. That is all the rows. What are you doing? Implement a set here first. Set of int. Okay. You can use an unordered set for less time complexity. For int I equals to 0, I going to n minus 1. My current equivalent is 0. Now for int j, starting from 0 going up till m minus 1, that is all the columns. So now my curve would be plus equals to matrix of ij, that is the value present at that index, multiplied by power of 2 to the power j, right? After this, curve, if curve is already present in the set, if curve is already present in the set, then push back I to the answer array, else push cur to set s, right? This is your pseudocode. Okay, but there is one problem in it. If you see the question, it says that the columns can go up till 10 to the power cube, that is 1000 columns can be there. So if the column number is 1000, we will need a binary number containing 1000 binary equivalents. That is, the binary equivalent of the maximum number can be 1 1 1 1 1 up till 1000 places, right? 1000 places. But a computer does not hold that memory. C++ does not provide us a big data, big long int, like something like that, to hold a binary equivalent of 1000 places. So it will give an error because of the overflow. Okay, let me show it to you by writing the code only, that it will give an error. How? See, what I'm doing is I'm initializing my answer vector, right? Now for int I going from 0 up till m I plus plus, m is the number of rows here. It is switched. They are using m as rows and n as columns. Okay, now I'm implementing long int, okay, to avoid any overflow as far as possible. It is currently 0. Now for int j is going from 0 up till n j plus plus, curve would be incremented by matrix of ij multiplied by power of 2 to the power j. Now if s dot find cur is not equals to s dot n, this is used to find if cur is already present in s, then answer dot push back the current row, else s dot insert, what do we say, cur. By mistake I forgot to initialize a stack, so I'm initializing it right now. Another set containing int, name it as s. All right, now return your answer. This should be a complete code. Running it now. Compile and find, try to submit. It will give a wrong answer because of the overflow. So you can see, and the test case 100 and 1010, it is even wrong answer. So our logic is correct, but we are using uh, inefficient data structures, inefficient data types actually. So what can we do? Here comes a second approach. Second efficient approach. All right. So as you can see, the try is sounding like tree, and that is what we are going to make. Okay. Now tree, you must have heard about binary trees. All right. But try something else. Try says make a tree of 0 and 1. That is, this is my head right now. Okay. It will be having two children. Why two children? Because I am having two only values, that is 0 or 1. All right. So if I am having two children, I am initializing a 0. Left will be storing 0, and right will be storing 1. So my first number is 1 1 0 1 0 1. So I go to 1, insert a node here. Again I go to 1, insert a node here. Then I go to 0 because it's 0. So it's 0, insert a node here. 1. So again 1 going to the right. Okay, then 0. Again left because it's 0. And then again right. All right. So my this right subtree type of thing is showing my first sequence, that right is existing, left is existing, right is existing, left is existing, right is existing. Okay. Now checking for the second one, that is this row. 0, insert a node here. Again 0, insert a node here. 1 now, insert a node on the right. Then two zeros back to back, so 0, 0. Then a 1, so right. Okay. To the third row. Now 1. As you can see, 1 is already existing. 0. 0 is not existing. So insert a 0. Okay. Then 1, make it 1. Then 1, make it 1. Then 1, then 0. So make it 0, that is left. And then 0, then make it 0, that is left. Okay. Now here is the twist will happen. What is the twist? You can see we got to 1. Okay. From here we went here. That is 1 was already present. We do not have to create a new node. Okay. Again 1. Again 1 is present. Do not have to create a new node. Now 0. Again present, no need to create a new node. Then 1. Again present, no need to create a new node. Now 0. Again present, no need to create a new node. And same for the last one. Again present, no need to create a new node. If I have not to create a new node anywhere, that means that this sequence has already occurred. Come with me, come to the same page with me. That is, if in the whole path we do not have to create any new node, that means the sequence has already occurred. Okay. If the sequence has already occurred, I've got my answer. This is the duplicate row. So insert that index into the answer. Moving to this one, 0 already placed, 0 already placed, 1 already placed, 0 already placed, 0 already placed, 1 already placed. Again, same case, duplicate, so 4. And similarly for this one, you will get 5. Are you able to understand what we are doing? We are using tree to describe a path. Again, say it with me. We are using tree to describe a path. All right. So I think that this solution approach was very easy for you. Do not have to take load that how will I write the code. I will tell you the easiest approach for the code for solving the POTD, okay, and maintaining your streak. Just stay with me. And did you understand the try data structure? That what it is doing? It is a type of an array. That is an array. That is, each node has got n branches. Okay, the simple. The try is used because we can initiate the searching in linear time. Like, if you observe a binary tree, you have to go from this to this for this for this, but in the array you just have to traverse the path given by the sequence. Okay, so this is the advantage for try. I hope this is clear to you. Now, you say that I will be writing the code for it. Yes, I can write the code for it. It is really easy. Don't panic about it. But for the POTD streak, I will tell you the easiest approach that you must have thought on the first basis only. The optimized approach. I think it is an optimized approach. Someone can contradict me. Okay. What I will say is that I have a matrix containing n rows. Yeah. I say that initialize a set. Use the STL initialize a set of uh, unordered set of type. Now type would be vector of it. Name it as s. All right. Traverse all the rows from 0 to n minus 1. Now, if s dot find matrix of I, compare the whole row if it is present in s, is not equals to s dot end, then answer will contain I, else add the row to matrix. Simple approach. Okay, and after that return your answer. Wasn't it simple? Just 3 to 4 lines of code and the problem is done. And it will run fine because we are not using any extra. We are using extra space that is of RC. R is the rows number and C is the column number. But these are the expected time complexity and space complexity only. What is the time complexity, by the way? Time complexity is O of R. Yeah, O of R, I would say. Or you can say RC because set will also use a certain time to find if it is present in the set itself. Okay, I think it was clear to you. All right, coming to the code real fast, and I think the last approach is just fine with you. So the thing we wrote, I just have to make some changes in it. Instead of int, it will store vector of int, and then if s dot find matrix of I is not equals to s dot n, in that case answer dot push back I, else s dot insert matrix of Okay, return answer. These were the only lines of code you have to write for today's PODD. Okay. These were the only lines of code. Let's try to submit it. Submitted. The 30 days streak has been completed. Now, when I understand that you must be happy that you have got the answer as from the set usage, and you have got the correct optimizer correct code. But it was really important to understand the two efficient approaches also, because they were brain consuming, they were brainstorming. Okay, so please don't skip that part. Please, it's for your sake that you understand the problems, so please understand those two efficient approaches also. I understand that optimized approach does excite you, but efficient approaches are also very important for your knowledge. Okay, thank you, have a nice day, and please, it's a sincere request, please do not forget to subscribe my channel and hit the like button. I will be really glad if you do so. Thank you for watching and have a nice day.